In this video, I'm going to be turning two Ridgid 18-volt batteries into a Ryobi 40-volt battery using an adapter. I'm going to start off with some 3D printed parts. Also going to need some wire. I'm going to pick a reasonably heavy gauge wire so that it won't melt on me. I'm going to start with a piece of extension cord here. I'm going to cut two wires at about 8 inches, which is a little bit excess for what we need, but it makes it easier to assemble later. And I'm going to use one wire at about 5 inches. Same thing, just cutting it off. Next, we're going to strip the ends of the wire just a little bit so we can put connectors on. Continue for all the ends. Next, these are the connectors I found online to use. They are a little bit on the small side, so I wouldn't really recommend them because it's a little hard to get them all lined up, but they do work, just crimping them on to the end. Now on the shorter wire, we're going to crimp one onto each end because this is the jumper between the two batteries. So we're just bending over the little tabs and crimping it onto the wire on both sides. Next, for the longer wire, we're going to grab one end on each, and we're going to crimp that on, because on this wire we're going to need the other side for the Ryobi end of things. So we're just going to crimp on this end. Next, I'm just grabbing a piece of metal, and here I'm using an old power supply from a PC, just because it seemed to be the right thickness of metal for what I was looking for. Almost anything would work as long as it's conductive. Just cutting off a square to work with. Now I'm going to line it up with the connections on this battery, trying to replicate them, making it a little bigger on the back end so I have something to work with though. Once I have two little squares, I'm going to notch off a piece, straightening it out. And now I'm just going to be cutting some little lines in here for tabs that we can fold over and use to crimp onto the wire. You want to make them thin enough that you can bend them over and crimp them well. Now just bending over the little tabs to crimp down on the wire. Just doing a light bend with the needle nose pliers. Later we'll hit them with the bigger pliers and crimp them as hard as we can. And then the same for the other side. And there we go. Here's a wiring diagram. So we're going to start from the positive of the Ryobi tool to the positive of the first Ridgid battery. Then we're going to go from the negative of that Ridgid battery to the positive of the other Ridgid battery. And then from the negative of the second Ridgid battery back to the negative of the Ryobi tool. Next, we need to connect the wires to the batteries, making sure to get the printed part over the wire first. Connecting the wires, making sure to remember the polarity, which I did mark on the 3D printed parts so that it hopefully won't get mixed up. Then just gluing in place with a glue of choice that'll make it hard. I'm using hot glue here, but if you want to use an epoxy of some sort, that would also work. Now doing the same to the other battery, making sure to make the jumper cable go from the positive to the negative. Make sure you've got the polarity right there. These are the screws I used, but you can probably use anything that would fit as long as it doesn't stick through too far. Now just feeding the longer wires up into the top piece and the short jumper wire down. Now to finesse the wires into their given slots. And once you've got it all sitting in there flush, just stick the screws in and screw it on. And now just going to take the excess wire and push it in to the adapter. And I'm going to use this little area here to pull out the excess. If you decide to cut your wire shorter, you'll have less excess depending on if you care about the looks of it. But it makes it much easier to install if you have a little bit extra to work with. So that's why I just pull a little bit through there. Now connecting the two connectors into the tool end on the Ryobi tool. making sure they line up, and then going to hot glue them in place, making sure to not leave excess glue that will prevent the two pieces from going together, making sure it's low enough, but just get in the right place. Also remember to check your polarity. In this case, I did accidentally get it inverted because the connection is upside down right now, so you got to watch out for that. Now here, just putting the little latching piece into the tool, making sure I got a spring that I'm just going to stick in place there, and then just gently pushing it down, yet again having to make sure the wires all line up with the slots. And screwing it into place. Now I did have to come back in after and flip my polarity on the wires, which was also a great reason to have the excess wire down there, because when I just cut them and flipped it, because I did get it inverted in this attempt. Connecting the batteries. But now, before you actually test it on the tool, I do recommend using a multimeter to make sure your polarity is right before plugging it into the tool and actually testing it. So here, just connecting the multimeter, I'm just going to set it to 200 DC and test the positive and negative. And if the red positive and the black negative are touching and you get a negative number, then that means it is inverted. And if you get a positive number, that means it is correct. So in this case, I want it to be positive when I have the red one connected to the positive line and the black one connected to the negative. Now here, just testing it out. Thanks for watching. Please subscribe.